Hello, my name is Andrew, and this is my final assignment for the Managing Machine Learning Projects course at Duke University. The assignment is to plan a project where we would build a machine learning model to solve a problem of your choice. The problem I decided to tackle was to identify the factors that lead to students leaving a martial arts school after years of training. Is there a problem? Yes, according to many masters at martial arts schools, or even just gyms in general, there is a great concern about people who leave after a significant time of training. This is particularly true for martial arts schools because the essence of success in training at martial arts really involves the student putting in a regular amount of time into their training. So if the student does leave after a year, then this really is a waste of time for both the master and the student. And masters would like to reduce this as much as possible. Can machine learning help? I think so. This is a standard classification problem, and most martial arts schools would have several years of attendance data that they can use to feed into the model. So it's relatively feasible to build such a model. Does someone care? Absolutely. As stated before, the martial arts masters do care about their students' attendance. And of course, the landlords of these martial arts schools, they would care too because this would help them maximize their revenue or at least make the cash flow of the martial arts school more predictable so that they can get their rent. The target user would be the masters of the martial arts school or at least the administrative staff who would handle the attendance of the school who would be looking into a problem like this. The problem, as stated before, is to determine the factors that lead to student churn after years of training and to build a profile for these students so the school can preemptively attempt to retain them. Why it matters: student churn leads to lost revenue and it also makes cash flow unpredictable. There is also an opportunity cost for both the master and the students. As for the current state, it really is hard to tell which students stay and which students leave at any given point in time. So the masters would respond almost reactively. They'll see that a student disappears for a while and they would either cold call them, asking them, hey, what's going on, or they'll send an email to that effect. And those have a unpredictable amount of effectiveness. Defining the success of this project, the expected impact is to increase the revenue at the martial arts school, or at least to increase the student retention. The outcome metrics would be a reduction in the churn of the students who have more than a year's worth of training. The output metrics would be the standard output metrics for classification problems, so stuff like the true positive rates, the false positive rates, precision recall curves, things like that. In terms of constraints, we want the model to be accurate, to be capable of accurately predicting the churn within at most 11 months, ideally sooner, so the school can have enough time to implement retain strategies. Let's look at some of the factors that would go into this model. So things like the number of classes the student attends in a given week, whether or not the student reserves through the online registration system and how many of these classes they reserve, maybe some demographic data like the student's age, the distance they commute to the school, or their current occupation, whether or not the student belongs to a family discount packages. So oftentimes martial arts schools invite several children who belong to the same family to go to the school at the same time. do the parents take advantage of these packages, and does that make them less likely to leave after a year? Obviously, the student's current level, whether it's in the form of a belt system or a grading system, and also how active is the student outside of classes. So do they attend some community events at the school? Do they go to team lunches, movie nights, things like that? Now let's look at the validation plan. I think we can start with some heuristics to establish baselines using just a year's worth of data. So an example of this would be, let's say, looking at the students who churn after a year, how many of them attend classes less than 2 times a week? And let's say the data comes back that 50% of students who attend less than 2 classes a week leave within a year, something like that. So that would be the heuristic baseline that we would use to grade all of the other models that we would attempt to build. Then we would use let's say a few sprints, just time box this development time to train a series of classification models. So I'm thinking of logistic regression models, decision tree models, maybe random forest models, depending on how complex we want to be, depending on the effort of time that we want to attempt at this. And for these models, let's look at 3 years worth of data, because 3 years will represent the time when people started coming out of the pandemic, and that should be more representative of the state that people are in today. We would go through several iterations of these models, and we would train these models. We would evaluate which one's the champion, and we would deploy this model to production, and we would analyze those learnings monthly. And then every 3 months, we would make an adjustment whether to retrain the model with new data or to update the model as needed. Now let's look at some of the ML system design. In terms of a cloud versus edge design, I determined that latency doesn't really matter. It's okay for this model to be dependent on the internet. And are the customers comfortable with the data on the cloud? I would say most of the data that we would use for this model, it should be okay to have this model and have this data in the cloud. But there may be some sensitive data that we need to look into. So for example, the person's age. We certainly don't want to be putting the people's addresses into this model directly. So we do need to get permission to use some of this data in our model. But for the most part, I would say it's safe to put this data into the cloud. In terms of offline versus online learning, there really isn't a need for continuous learning, and it's easier to implement and maintain an offline model. So let's go with an offline design. And for batch versus online predictions, same thing. There's no need for immediate predictions, so I'm going with batch. Now looking at some of the production risks, first of all, there's training skew. In particular, I'm thinking the data so since we're using 3 years worth of data, the data at the start of this time period, so the 2023 data when people are coming out of the pandemic, that may not necessarily be reflective of the current situation, so that may skew some of the results, so we'll need to look into that. There's obviously data drift, so particularly for martial arts schools, if you think about a person's age, typical students start when they're young, and then they grow into teenagers, and then they grow into young adults. So that shift in demographic may lead to changes in the way they train. And there's also concept drift. So for example, given the current global economic conditions, there's some assumptions about a student's employment situation that the models may not take into account. So, for example, you would think that a student who comes multiple times a week, they're likely to return after a year. But it may just be a situation where that person happens to be unemployed at the time and they have more free time, so they decided to come more often. Whereas later on, when they get a new job, their availability will just be less and they'll start coming less. So there are things like that that we'll need to look into. But ultimately, it's important to retrain and update the model at regular intervals to ensure their usefulness. Luckily, for a problem like this, the data is readily available and the models in question are rather simple to build. So it's definitely worthwhile to proceed with a machine learning project like this. Thank you for your time and have a good rest of your day.